All right, this is just a quickie example for explaining binomial probability. I'm going to use this example where a social scientist claims that 60% of all high school seniors capable of doing college work actually attend college. We're assuming his claim is true, and for a sample of 15, we're going to find the following probabilities. And the only probability that I'm actually going to find is this part B, so that I can explain that. So our P is 0.6, and our N is going to be 15 here. And so I'm asking us to find the probability that my random variable um, is greater than or equal to 10, because at least means that's the smallest amount. Now, in using a calculator, we cannot find that particular probability. So here's what you need to understand, and here's the thing that I really want to explain. So a binomial probability distribution is a discrete distribution. So what it has going on here is bars, and each of these bars represent a random variable. So let's just call this one our random variable bar of 10, and this one would be 11, 12, 13, 14, and 15. So each of these bars, if we're finding the probability that x is greater than or equal to 10, this is what we're finding. We're finding this one here, and 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 this one here. However, the calculators cannot find that. They can find less than or equal to a certain value. So they can find these values over here. So what we find is that this value is 9 over here. So we have this being equal to 1 minus the probability that x is less than 10. That's actually the complement of being greater than or equal to 11. But less than or equal to 10, you see there's no distinction here. It's either 9 or 10. So less than 10 is actually 9, 8, 7, 6, 5, blah, 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 so on and so forth, on down here to our bar that would represent 0. And so that's what we need to calculate. We actually need to calculate this being the probability of being less than or equal to, less than or equal to 9. So x is less than or equal to 9 here. And that is going to give us our probability for this, but then that is just this portion down here. Let me change this to a different color. So you have this bar here, and this bar here, and this bar here, and this bar here, and this bar here, on down to that bar there, represented by this probability of P being less than or the probability that x is less than or equal to 9, and we still want to find that over there. So of course that leads us to 1 minus the probability that x is less than or equal to 9. So what I do here is I say, oh, well, I can do this on my calculator. This is a binomial CDF, and I'm not going to write out total binomial, just binom CDF. And then I put in here that my n is 15, and my P is 0.6, and then my actual value that I want in here is 9. Once I get that value, I do 1, subtract that value, and that actually gives me the value that I'll want over here. Now, I'm not actually going to do that, because what I really wanted to focus attention on here was this complement idea, because I think that's what's causing more stress than anything, is the probability that x being greater than or equal to 10 is these blue bars, but we can't compute those blue bars using a calculator. So what we would do instead is we would turn it around and we'd say, okay, well, that's 1 minus the probability of being less than that, but being less than 10 is actually being 9 or 8 or 7 or 6 or 5 or 3, so on and so forth, down to 0. And so that's less than or equal to 9. So I hope this helps.